All right, in this section, we're going to talk about tests with two populations. This is also a hypothesis test. Hypothesis test. You notice it's two population. It just means now we're going to have we compare now two population by looking at two samples. So two samples. So we'll take one sample from one group, or one population will take another sample from the other population. They will compare those two samples to do hypothesis test. So this corresponds to chapter 10 of the book. The first part corresponds to section 10.3, the comparing two means, section 10.1 and 10.2, and match pairs 10.4. So when performing tests involving two or more populations, because now we have two different populations or two different groups, it is important to specify which population is population 1, which population is population 2. Before, we only had one population, so we could call it like mean mu. Okay, there was only one population, so there was a mean of the population. But now we're going to have two different groups. So when we talk about mean, like, are we talking about mean of the first group, or are we talking about mean of the second group? So we need to kind of label that differently. So let's look at part A. Claim says full-time PCC students are more likely to transfer to four-year university than full-time GCC students. Okay, so I see there is PCC students and there's GCC. We have two different populations, PCC and GCC. So, and we're looking at transfer rate. So this is like percentage of people who transfer. So this is proportion. So you notice that they're using P. You also notice that it's just not P, it's P1 and P2. So let's say this is population proportion for PCC, and the other one is population proportion for GCC. Because we're going to have two transfer rate, which is percentage of people who transfer. So we have to kind of specify, are you talking about PCC students one or the GCC one? So P1, we can label P1 as PCC, and P2 as GCC. And the claim is, it says PCC is higher than GCC. So I want to say P1 is bigger than P2. So this will be a very typical way to compare first population with the second population. Okay, I'm going to have you try part B, and let's come back and meet at part C. All right, let's look at part C. The claim is the Muggle magic memorization method increases your memory, okay, whatever that is. The experiment gives you 10 minutes to memorize a list of 100 names. I'm going to do horribly with that. And ask to recall as many as possible. Okay, so I think they're hoping that after going through this method, you can recall more names because you have more memory now. So the result is given before. So I notice that subject A through I, so there are a bunch of people tested, and you notice that each person has two numbers. The first number is the score they got before this method, and second number is the score they got after this method, hoping the second number is bigger than the first number. Here we say we have matched pairs, because even though we have two set of samples, these numbers are not random numbers. They come from the same person, typically before and after. So we measure something before, and for the same person, we measure something after. So we get set of numbers. That's why it's called matched pair. We get pair of numbers from each person. So when we have this kind of situation, what we do is you create this difference sample. So difference denoted as D. So what we care is like how much they improved. So what we do is we can do L1 minus L2. I like to look at it as L2 minus L1, which is after minus before, right? So just look at the difference. So look at person A. This person started from score 9 and then it became 19. So I'm like, wow, 10 points better. So difference is going to be 10 because it's 19 minus 9. And same for the second person. First score is 10, and the second score is 20, improved by 10 points. Third person, unfortunately, didn't do so well. Started from 20, ended up at 19. That means lost a point, so -1, and so on and so forth. So these are new. This is new sample that we're going to create. That's the difference, so denoted as D. So here what we're trying to say is, oh, I want the average of this difference. So some difference is going to be positive number, some difference is going to be negative number. What they're trying to say is on average they improve the score. That means on average they want the numbers to be positive. So I want to say claim is the mean difference is positive. Again, is a strict inequality, so that's going to be HA, and H naught is going to be less than or equal to. All right, so we talked about how to set up the claim when we are comparing two populations. Now let's talk about how to actually perform hypothesis test. First, you're going to look at comparing two proportions. So proportions, notice that it's going to be P of some sort. Random variable distribution, don't have to worry too much about it here. Just using z-score, you'll see it in the calculated function key. Calculated function key, again, we're going to kind of do the same thing. We'll do stat, we'll do tests. And instead of selecting one prop z test, because now we're comparing two populations with two samples, we'll use the option 6, 2 prop z test. Notice that is 2 prop. That means we are comparing two proportions with two samples. So instead of one prop, we're using 2 prop in this case. All right, let's look at the next example. The table below lists result from simple random sample of front seat occupants involving car crashes. Use a 0.05 significance level to test the claim the fatality rate of occupants is lower, I'm going to underline lower, for those in the car equipped with airbags. So they're saying with the airbag, fatality rate is lower than without. So let's say this is P1, P2, so airbag versus no airbag. So again, we have two population. We have a sample from the ones with airbag, and then we have sample from ones without the airbag. And we're going to try to compare the proportion. And the claim is that the proportion for airbag is lower than the proportion for no airbags. So if I have to write that out, claim is airbag is lower than, so that means less than no airbag. So that means H naught, HA. Again, this is strict inequality, no equal signs, that goes with HA. That means H naught is going to be the other way around. This is the original claim. So this is our setup. When you guys are doing this kind of questions, it's very important to label this. Otherwise, if I didn't see this part and this part, I would not be able to tell it's like what's P1 and what's P2, right? So it's very important to indicate that like airbag is P1 and no airbag is P2. Now I'm looking at the data here, total number of occupants. So this is my sample size. So I'm going to label this N1 and 2. Again, we have two different samples. So the first sample size is N1, second one is N2, and this is X1, X2. So how do I find the p-value? What I'm going to do is I'm going to use 2 prop z test. 2 prop z test. Once you go there, it's going to ask you a bunch of information. X1, it's going to ask for N1, X2, N2. So I'm just going to put in those numbers: 11541, 52, 9853. And you look at this symbol, inequality, this inequality, this inequality. I'm going to choose less than equal to. Again, it comes from HA. Then I'm going to just go calculate. And p-value you're going to get. They give you a bunch of information. The second one is p-value 0.027, so 0.028 if I round off. All right, so everything else from now on is going to be basically the same as one population. Our alpha is given, not given, 0.05, so this is less than alpha. So our decision is, so again, p-value is small, so our samples, that means our samples are unusual, and we reject things that are unusual. So my first step is reject H naught. That means we're going to support, automatically means support HA, because H naught and HA are opposite statements. So again, reject H naught always goes with support HA, and fail to reject H naught always goes with fail to support HA. So finally, I'm going to make a conclusion about the original claim. And notice that original claim is HA, so I'm gonna have to look at what did I say to HA. I supported HA statement. That means I'm gonna support the original claim statement as well. So basically we're gonna support the original claim. That means we have sufficient evidence to support the claim that the fatality rate for P1, which is the airbag, is lower than the without. All right, now let's look at the next one where we're comparing two means. So next part, two means, independent samples with known population standard deviation. Again, when we test for the mean, we have two cases. One is when we know sigma, which is the population standard deviation. And the second case when we do not have sigma. So first case, we'll use Z, the normal distribution. And the second case, when we don't have sigma, the population standard deviation, we use the student T distribution, right? So that's going to be the difference. And it's going to work basically the same way here. Independent samples, we have two samples with known population standard deviation. We're going to use the Z test. So random variable distribution Z. Random variable, you don't have to worry too much about it. It's just x bar 1 minus x bar 2. We're just looking at difference of two sample means. Calculated function we're going to use is kind of same stat. We're going to go to test. We'll look at third option. It says two sample Z test. Two sample because now we're comparing two population. We're going to have two samples. Z test because we know the population standard deviation sigma. So I'm going to label sigma. So that's the function code we're going to be using. Okay, let's look at the example then. Here we are comparing two engine type. So there's engine type 1 and engine type 2. If you look at the last statement, second to the last statement, does the data indicate that engine 2 has higher RPM than engine 1? So I'm going to translate that as on average, does engine 2 have a higher RPM than engine 1? So here I'm going to do mu2 bigger than mu1. That's going to be our claim. Obviously, this is going to be my population number 1. This is going to be my population number 2. So the claim is going to be, usually we're going to write mu1 first and then mu2. So mu1 is less than mu2. So I'm just rewriting this. mu1 is smaller than mu2, or mu2 is bigger than mu1. So we'll just translate that to that. Again, I'm looking at the inequality we use. It's a strict inequality. There's no equal sign. So that's going to be our HA. So mu1 less than mu2. And H0 is going to be the other way around. So it's going to be like this. This is my original claim. Here, the original claim happened to be HA. But if the claim happened to be test the claim that they have the same average, then the claim is going to be mu1 is equal to mu2, which will be H0. I don't want you to think that claim is going to be always HA, because sometimes the way it's phrased, depends on the way it's phrased, it could be H0 as well. All right, so this is our step here. Sample mean, so I'm going to label this x1 bar, x bar 2 here. Sample population standard deviation, so sigma 1, sigma 2. And then the sample size, they say 30 engines of each type. So they didn't say it, but I'm going to say N1 is 30, N2 is also 30. And so I'm going to use two sample Z test. And it'll ask you for a bunch of numbers to input. Sigma 1 is going to be 50. Sigma 2 is going to be 60. X bar 1 is going to be 1,500. X bar 2 is, N1 is going to be 30. X bar 2 is going to be 1,600. N2 is going to be 30. And the last one, you'll notice that it says mu1 dot dot this, or this, mu2, right? That's why I want to pick mu1 as the first one and the mu2 as the second one, so because the calculator kind of puts it that way. I want to pick the right inequality. So I'll press that and then calculate. My p-value is going to be, it says 1.17 e negative 12. Again, p-value is like 1 point something. How can p-value be more than 1? But if you read the whole thing, e negative 12, that means it's like 0.000000. You got to move your decimal 12 to the left. So it basically is 0, which is very small number. So decision and conclusion. So p-value is almost 0, which is obviously less than alpha. So again, when p-value is small, we have something unusual. Our samples are unusual. We reject things that are unusual. So I'm going to reject H0. That means I'm going to support HA. And my final conclusion is I have to look at what my original claim was. My original claim happened to be HA. What did I do to HA? Here I say I support HA statement. That means I'm going to support the original claim statement as well. So we have sufficient evidence to support the claim that the second engine type 2, has higher round per RPM than engine type 1. Engine 1. All right. So that's that. The next question is going to be kind of similar to what we just did. Here I'm going to have you actually try it yourself. The difference between number 4 and number 5 is here. It says the unknown population standard deviation. That means sigma is not going to be given. But if you look at the data here, it gives you S, which is the sample standard deviation. So instead of using 2 sample Z test, I'm going to be using 2 sample T test. That's my hint. I'm going to have you figure this one out yourself. And I'll meet you at number 6. All right, let's look at number 6. This is match paired one. So this is a very typical way to organize match pair. Again, this is like I'm comparing each person's before and after score. So let's say L1 is score before, L2 is score after, then L3 I'm going to let that to be after minus before. And then XD, notice that there's a D, that means there's a difference, so this is mean difference. So the sample mean difference, the population mean difference. So we have 2 samples, one for before, one for after. We'll merge that into one sample, which is the difference. That we'll just test on that different sample. S represents the standard deviation of the difference from the sample. All right, so this is going to be T distribution. Calculator's function key. Basically, it's going to be T test because even though we have 2 samples, we basically merged that into one sample. So we'll do T test on L3. So let's look at the example here. A study was conducted to investigate how effective a new diet was in lowering cholesterol. Results for the randomly selected subjects are shown in the table. The differences have normal distribution. Where does that normal distribution come from? We kind of need it for theoretical reasons, so you don't have to worry too much about it. So the question here is, are these subjects' cholesterol level lower on average after the diet? Use 5% level. So again, each person was measured, their cholesterol level was measured twice, before this diet and after this diet. So let's say this is L1 and this is L2. So again, what we care about here is how much they improved or how much the cholesterol level has gone down. So we're going to create this list L3. Basically, that's the difference. L2 minus L1. So after minus before. So look at person A started from 209, went down to 199. Nice. Lost 10. So it's going to be 199 minus 209. So we're going to get negative 10. Fine. Second person also started from 210 and went down to 207. Good. Lost 3. So negative 207 minus 210, you'll see is negative 3. And so on and so forth. Let's look at person D. Started from 198, went up to 209. Oh, that's not good. So if you did 209 minus 198, that will be positive 11. Well, that's not good. So this is good. This is not good, pretty much. So what we're going to do is we're going to do that for each person. So we're going to get negative 16 here, 11 and 1, negative 15, negative 27, negative 17, negative 21. So again, we're going to translate our claim. The claim was, are the subject cholesterol level lower on the average after the diet? So I want it to be negative. That means it's lower, right? So we can write claim as, on average, the mean difference is negative number. I want those numbers to be negative on average. Some people lost a lot. Some people actually gained. So claim is on average, does it lower? That means an average is less than 0. H0, H0 and HA. Again, this happened to be HA again. And H0 is going to be bigger than equal. So this is going to be my original claim. So how do we actually calculate the p-value to test the claim? Well, here's my new list I created. So basically, I don't need L1 and L2 anymore. I can just test L3. So that's why it becomes just t-test. I don't need 2 samples anymore. I just have 1 sample. So I can put L3, those numbers I got for the difference, into L3 and use that as the data. So go to t-test, and this time we actually have the data. So we'll click on data option. They ask for mu0, list, frequency, and then the inequality sign. So mu0 is, where is your mu from H0? I'm looking at H0. 0. The list is L3. Here I happen to put in L3. If you put it in L4, then you're going to just type in L4. Frequency is going to be always 1, and HA, the inequality is less than, so I'll pick that one. And when you calculate that out, your calculator will give you p-value to be 0.013. So again, it's smaller than off. So that means my sample is unusual, and again, I reject samples that are unusual. So I reject H0. That means I support HA. So my final conclusion is the original claim happened to be HA. What did I say to HA? I supported HA statement, so I'm going to support the original claim statement. So conclusion is we have sufficient evidence to support the claim. The diet lowers the cholesterol level. All right, I think we're done with this worksheet.